Okay, this is lesson 7.5, solving linear trigonometric equations. To solve means that you're looking for all values of a variable that satisfy the equation or make it true. In these examples, we're going to be solving for theta for specific trig functions that give us a certain ratio. Some will be able to come up with exact values, some will come up with approximate, and we'll talk about when you can get an exact value answer and when the approximate answer is the best one that we can come up with. Since periodic functions repeat, there usually, or not usually, there will be an infinite number of solutions. So we must restrict the domain in order to get a specific number of solutions. And you'll see domain restrictions as a part of most of your trig equations that you're asked to solve. So we'll discuss that as well. In order to solve, though, we need to remember how to do two things: to sketch an angle on the Cartesian plane and the cast rule. So quick recall of the cast rule. The cast rule tells you on the Cartesian plane which functions will be positive in which quadrants. So quadrants, we have quadrant 1, quadrant 2, quadrant 3, quadrant 4, and the cast rule tells us that quadrant 4 cosine is positive. Quadrant 1, all trig functions will give you positive ratios. Quadrant 2, only sine will give you positive ratios. And in quadrant 3, tan will give you positive ratios. Now, this cast rule works for the primary trig ratios. For secondary trig ratios, they're partnered up with their reciprocals. So, for example, quadrant 4 cosine is positive, but so is secant, because cosine and secant are reciprocals. In quadrant 3, tan and cotan, because their reciprocals are positive. And in quadrant 2, sine and cosecant are positive. In quadrant 1, all trig functions will give you positive ratios. So, how do we solve a trig equation? Well, let's look at our first example. In example 1, it says find all angles of theta for 0 to 2 pi, where sine theta equals 1/2. So, 0 to 2 pi is your domain restriction, and all that means is that on the Cartesian plane, that's one counterclockwise rotation on the Cartesian plane from 0 to 2 pi. So starting at 0, we could rotate all the way around to pi over 2 or pi or 3 pi over 2 or all the way back to 2 pi. And within that single rotation counterclockwise, we should be able to find all of our solutions. And we want ones where sine theta gives us 1/2. So that's saying that sine theta gives you a positive ratio. So where is sine positive? Well, according to the cast rule, sine's positive in quadrant 1 and quadrant 2. So we're going to make two sketches. We're going to make one sketch for quadrant 1 and one sketch for quadrant 2, because that's where sine theta is positive. So that's where both of our solutions should be. So let's make a sketch in quadrant 1 first. So in quadrant 1, we have some angle theta that gives us a positive ratio for sine. Now sine is just opposite 1 over hypotenuse 2. So by looking at our sketch, we should be able to piece together what that angle is, because 1 and 2 are significant. How are they significant? Well, they're in a special triangle. The 1 root 3 2 special triangle, or the 30, 60, 90 special triangle, or the pi over 6, pi over 3, pi over 2 special triangle. And in this case, theta, across from the smallest side, would be the smallest of those angles. So theta would be pi over 6. Since we're looking for multiple answers, potentially, we're going to designate this theta 1, or our first answer. Okay, so our first answer, quadrant 1, we found it by labeling two sides of the triangle, realizing that that was a special triangle, labeling the third side to match up which angle theta must be. Since it's across from 1, it was pi over 6. If it wasn't a special triangle, we could use inverse trig functions to solve for that angle, and then we would know what the angle is. But since it's special triangle sides, we know what the angles are in special triangle angles, so we can find theta directly. Quadrant 2 answer. So sketch again. We've got an answer in quadrant 2. This time it would be our second theta value, so I'm going to call it theta 2. And sine of theta 2 gives us 1 over 2. Now 1 is opposite because it's sine, and 2 is hypotenuse. And again, we have another special triangle angle, or special triangle sides. This is the same special triangle, which makes sense because this beta is a related angle to our theta. This beta is pi over 6, and our theta is related to that beta. How is that theta related? Well, 1/2 rotation would be pi, so an angle in this second quadrant, theta 2, would just be pi minus our beta. Quadrant 1, our beta and theta were the same, pi over 6. In quadrant 2, that beta is still that pi over 6 because that's the angle inside our triangle, which makes theta 2. If we write that as a fraction over 6, that would be 6 pi over 6 minus pi over 6 is 5 pi over 6. So there's our second solution. Theta 1, pi over 6. Theta 2, 5 pi over 6. Eventually we might be able to get to a point where our solutions, we don't have to sketch the second quadrant. Since we know the angles in the second quadrant, an angle in the second quadrant will always be defined as pi minus your x, right? So if you found your x in your first angle, pi over 6, then your second quadrant answer would just be pi minus pi over 6. And that would be true if it was in the third quadrant. It would just be pi plus pi over 6. If the answer is in the fourth quadrant, it would be 2 pi minus pi over 6. So the second sketch helps you visualize the answer, but it's unnecessary to come up with the second answer if you remember how you define angles in those other quadrants. So for an example very similar to this, you can try practice 1. We're going to move on to one that's a little bit different and look at practice 2. Or sorry, example 2. So this asks us to solve cos theta equal to negative root 3 over 2. So we're now looking in a domain that's bigger than just 0 to 2 pi. We're looking from negative 2 pi to 2 pi, which means that we can get to our terminal arm by rotating forward on the Cartesian plane or backwards on the Cartesian plane. What this doesn't change is our first step. We have to ask ourselves, where's cosine negative and negative because we have a negative ratio? Well, if we use the cast rule will show us that cosine's positive in Q4 and Q1, which means it's negative in quadrant 2 and quadrant 3. So all of our answers will be in quadrant 2 and quadrant 3. So here we go. Q2, Q3, and that's where cos theta is negative. So I'm going to draw my terminal arm in quadrant 2. And we'll develop our first answers by looking in quadrant 2. How can we get there? Well, we can get there in two ways. We could get there by rotating counterclockwise, which is positive. That can be, we'll call it theta 1. But we could also get to this terminal arm by rotating backwards. And we'll call that theta 2. What this all depends on is what that related acute angle is, what that angle inside that triangle is, because that's going to help us get our thetas. So what do we know about cos theta in quadrant 2? Well, we know that it's root 3 over 2. Cosine is adjacent over hypotenuse, so that means we have adjacent root 3 over hypotenuse 2. One of them needs to be negative. Since we're to the left on the Cartesian plane, it's root 3 that's negative. And again, this is the 30, 60, 90 special triangle, or the pi over 6, pi over 3, pi over 2 special triangle. Since this side would be 1, that makes our beta pi over 6. So what's our first answer? Well, our first theta, rotating counterclockwise, we would end up pi over 6 short of a pi rotation. So that would mean our first theta would be pi minus pi over 6, which is 5 pi over 6. So that's our theta 1. Rotating backwards is a little bit trickier. We're rotating backwards pi, So that means in the reverse or in the backwards rotation, that means that's a negative pi rotation. And then we're continuing to rotate backwards another pi over 6, which is another negative pi over 6. And together, that would be negative 7 pi over 6. So we have two answers in the second quadrant. One by rotating counterclockwise or in the positive direction, 5 pi over 6, and one by rotating backwards or in the negative direction, which is negative 7 pi over 6. Negative pi because that's half a rotation, and then an extra negative pi over 6 because we're rotating still backwards. Okay, so there's two answers, both from quadrant 2. To get our answers from quadrant 3, we do it pretty much the same way. Draw your terminal arm in quadrant 3. We can get there by rotating clockwise or counterclockwise. So right, counterclockwise or clockwise. We'll call this theta 3, and we'll call this one theta 4. Our beta, our related acute angle, doesn't change because we're still working with this ratio, negative 3 over 2, and that's still our adjacent, negative root 3, and our hypotenuse 2. Our opposite side is still negative 1, which means that our related acute angle is still pi over 6. So if we're rotating into the third quadrant in the positive direction, or theta 3 as we called it, that would be pi, 1/2 rotation, plus pi over 6, which is, well, 6 pi over 6 plus pi over 6 would be 7 pi over 6. That's our theta 3. And if we're rotating backwards or in the negative direction, that would be a negative pi, but then we fall up a little bit short of rotating a whole negative pi. So that would be negative pi, and instead of adding, or instead of subtracting pi over 6 because we continued to go another pi over 6, we fell pi over 6 short, so we'll add a pi over 6 because we're short of a negative pi rotation, which would give us negative 5 pi over 6. All right. The tricky angles to come up with here are the ones rotating in the negative direction. So I want to show you another way to think about the negative direction angles, and it might help you come up with these negative rotation angles a little bit easier. Another way to do it would be to say, I'm going to say or we could say that theta 4 is defined as, ignore the fact that we're going backwards for a second and just think of it as if we were going forwards. This would be a pi rotation, and then we'd fall out pi over 6 short. So that would be pi minus pi over 6 if we were rotating in the correct direction. Since we're rotating backwards, we want to take that whole thing and make it negative because we're rotating backwards. And now if we simplify and reduce this, pi minus pi over 6 would be 5 pi over 6, but we have it negative, so therefore it's negative 5 pi over 6. It doesn't matter which way you think of this angle. Whichever one allows you to come up with the correct answer most efficiently is the way you should think about it. But there is two ways to think about how to define those negative angles. You'll only be able to decide through practice or maybe through which explanation made the most sense. If neither made the most sense, then it's just practicing and seeing which one becomes the easiest to familiarize yourself with. And then that's the one you'll use to define those negative angles. Okay, that's our first video from 7.5, and that's solving simple trig equations. We're going to do a second video where we do 2 more examples that are a little bit more complicated. Thanks for watching.